So if you're building with AI agents, you've probably hit that wall, right? Where your super smart agent just suddenly gets confused or distracted or just goes completely off the rails. Well, it turns out there's a name for the skill that fixes this. And according to some of the biggest labs in the world, it is the #1 job for AI engineers right now. To really get why, we need to start thinking about AI a little differently.
To get our heads around this, let's use a really simple but powerful analogy, one that folks like Andrej Karpathy have talked about a lot. Think of a large language model, your GPT-4, your Claude 3, as a super powerful CPU. I mean, it can reason and compute like crazy. But its context window, the space where it holds all the info for a task, that's like RAM. It's lightning-fast working memory, but here's the catch. It's limited, and it's totally volatile.
And that leads us to the one crucial question that every single agent developer is wrestling with. What happens when that limited working memory, that RAM, gets completely overloaded? Because trust me, with agents trying to do long, complex tasks, calling all sorts of different tools, it fills up, and it fills up fast.
Yeah, when it overflows, things get messy. You start seeing these really critical context failures. You get things like context poisoning, where just one little piece of bad information throws the entire task off course. Or context distraction, where there's just so much noise that the model can't focus on what's important. It might fail to prioritize the right info or get totally paralyzed by data that contradicts itself. This is exactly what turns a promising agent into a completely unreliable one.
So, if the LLM is our CPU and the context window is our volatile RAM, what's the solution? Well, what are we missing? We need an operating system. We need something that can intelligently manage that precious, precious RAM. And that right there is exactly what context engineering is all about. So to define it, context engineering is basically the art and the science of strategically curating what goes into that working memory. It's not just about cramming more and more data in there. No. It's about putting precisely the right information at precisely the right time for every single step the agent is about to take.
And just like the OS on your computer, this AI operating system has a few core functions for managing all that memory. We can break them down into 4 key strategies that you'll see all the top agent developers using today.
First up is writing context. Think about it. If your computer's RAM is full, but you've got important stuff you'll need later, what do? Simple, right? You save it to the hard drive. Writing context is the exact same idea, but for an AI agent. It's all about saving information outside of that immediate crowded context window.
And this isn't just theory. We're seeing this out in the wild. For instance, Anthropic's really advanced research agents use a scratch pad to literally write down their plan before they even start a complicated task. That way, they never lose track of the main goal. And, features like ChatGPT's memory, that's a form of long-term storage, letting the agent remember key facts about you across totally separate conversations.
Okay, so saving information to the hard drive is only half the battle, right? You eventually have to bring it back into RAM so you can actually work on it. This brings us to our second strategy, selecting context. This is the art of pulling only the most relevant pieces of information back into the context window, exactly when they're needed. This is where techniques like retrieval augmented generation, or RAG, are just an absolute game changer. Instead of dumping 100 different tools into the agent's context, you can use RAG to let it search through their descriptions and select only the, say, 3 tools it actually needs for the next step. Or it can pull in a very specific procedural memory, like your company's style guide, right before it starts to write a blog post. It's about being surgical, not just throwing everything at the wall. All right, on to strategy number 3. So what if the information is important, but it's just massive and it's taking up way too much RAM? Well, the computer analogy is super simple. You zip the file. For our AI agents, we call this compressing context. I mean, this is such a brilliant way to manage all that token bloat. If you've ever used Claude for coding, you've probably seen this in action. It'll auto-compact the conversation history when it gets close to its limit. That's compression. Other agents will summarize a section of work they've just finished, or maybe just trim the oldest, least relevant messages from the conversation to make some room.
And that brings us to our 4th and final strategy, isolating context. How does your computer run a web browser, a code editor, and a music player all at the same time without them interfering with each other and crashing? Well, it isolates them. It gives each one its own little dedicated memory space. And guess what? We can do the exact same thing for our agents.
This is the whole principle behind these multi-agent systems you hear about. Instead of one agent with a gigantic, messy context window trying to do everything, you create a team of specialist agents. Each one has its own smaller, focused context window, and they work together on the bigger task. This lets the whole system process way more information than any single agent ever could.
So, let's do a quick recap. Think of this as your cheat sheet. We've got writing, which is like saving to a hard drive for later. Selecting is loading just the right files into RAM. Compressing is like zipping those files to save precious space. And isolating is like running multiple programs at once so you can expand your total capacity. Mastering these 4 strategies, really getting them down, is how you transform an agent from a brittle prototype that breaks if you look at it funny into a truly robust, production-ready system. But before you can really start putting them to work, there are a couple of things you absolutely have to have in place first. Look, you can't effectively manage what you can't see. It's that simple. Before you can be a good context engineer, you need a dashboard for your AI's operating system. These are what we call the table stakes. They're the non-negotiable entry fee to play this game seriously.
And those table stakes are basically 2 things. First, token tracking. You have to be able to see how much RAM your agent is using at every single step. Second, evaluation. You need a rock-solid system to measure if your changes are actually making things better. I mean, compressing your context is totally useless if it makes the agent's performance worse, right? You have to track and you have to test.
So, when you put all of this together, the problem of overloaded RAM, the operating system analogy, those 4 strategies and the prerequisites, you really start to get why this is becoming such a massive deal.
And hey, you don't have to take my word for it. The team at Cognition AI, you know, the folks who made the Devon coding agent, they put it this bluntly. This isn't just some neat little trick. It's fast becoming the core skill for building anything meaningful with agentic AI.
So at the end of the day, what this all boils down to is pretty simple. Learning how to write, select, compress, and isolate context, that's what separates the hobbyists from the pros. It's the key that unlocks agents that aren't just clever in a quick demo, but are actually reliable and effective out there in the real world.
Which, leaves us with one final big thought. As we get more and more sophisticated at managing an AI's working memory, as we decide what it pays attention to, what it remembers, and what it forgets, are we just building more efficient tools, or are we, in a very real way, becoming the architects of their minds?